74,000 years ago, on the island of Sumatra, a volcano exploded. Not in the way volcanoes usually explode. This was a supervolcanic eruption, the largest on Earth in the last 2 million years. In a matter of days, it ejected roughly 2,800 cubic kilometers of rock, ash, and gas into the atmosphere. To put that in perspective, the 1980 eruption of Mount St. Helens, one of the most destructive volcanic events in modern American history, ejected about 1 cubic kilometer. Toba ejected 2,800 times that. The eruption happened so fast that the ground beneath it collapsed, forming a caldera, a crater, roughly 100 kilometers long and 30 kilometers wide. Today, that crater is filled with water. It's called Lake Toba, one of the most beautiful lakes in the world. You would never know what happened there. The immediate effects were catastrophic. Ash fell across South Asia, Southeast Asia, and East Africa. In some places, layers of ash up to 15 centimeters thick. The eruption injected massive amounts of sulfur dioxide into the stratosphere, blocking sunlight. Average global temperatures may have dropped between 3 and 3.5 degrees Celsius for several years. Some estimates say as many as 6 years of near-perpetual winter. Vegetation collapsed, food chains collapsed, and somewhere in that darkness, the human population collapsed too. Here's where it gets personal. Your DNA tells a story that scientists call a genetic bottleneck. At some point in the past, the estimates range from 50,000 to 100,000 years ago, the genetic diversity of all humans on Earth fell dramatically. Not because humans were geographically separated, but because there weren't many of us left. The DNA of every person alive today suggests that all 8 billion of us descend from a population that may have been as small as 10,000 individuals. 10,000 people on the entire planet. For decades, the explanation seemed obvious. Toba did it. The volcanic winter, the ash, the crop failure, the starvation. It made perfect scientific sense. A supervolcanic eruption of that scale, hitting at exactly the right time, it would explain why your DNA looks the way it does. This became known as the Toba Catastrophe theory, and it dominated paleoanthropology for over 2 decades. Then the evidence started getting complicated. Sites in South Africa, far from Toba, across the Indian Ocean, showed no interruption in human activity after the eruption. People were still making tools, still living at the same sites, still behaving normally. Sites in India told the same story. Sophisticated stone tools appeared both before and after the Toba ash layer, made by the same populations using the same techniques. In Ethiopia, in Indonesia, in China, the pattern repeated. Human populations that should have been devastated appeared to have survived, and in some cases adapted. A 2021 study published in PNAS used new, refined climate models and found something unexpected. While large parts of the Northern Hemisphere may have experienced significant cooling, up to 4 degrees Celsius, most of the Southern Hemisphere experienced little to no temperature drop. The effects of Toba were not uniform across the planet, which means not everyone suffered equally. Some populations in some regions may have barely noticed. Then, in May 2026, a major review published in Science Daily summarized where the science now stands. While the Toba supereruption was undeniably massive, one of the most violent geological events our species has ever witnessed, the evidence increasingly suggests it was not the primary cause of the genetic bottleneck in our DNA. The real bottleneck may have happened earlier, possibly between 150,000 and 130,000 years ago, linked to a period of extreme ice age conditions during what geologists call marine isotope stage 6. Toba didn't save us or destroy us, it tested us. And here's what that test revealed. Humans at Pinnacle Point in South Africa were eating shellfish and using ochre before the eruption and continued after it without interruption. At Jwalapuram in India, archaeological layers directly beneath and above the Toba ash were so similar that the same population clearly lived through the eruption and kept going. These were people living in small groups, with no warning, no preparation, No understanding of what was happening. Watching the sky go dark, the air fill with ash, the plants die around them. And they adapted. They found new food sources. They shared what they had. They kept their knowledge alive and passed it to the next generation. Here's what I think is the real story of Toba. Not that it nearly killed us, though it may have in some regions, but that it revealed something about us that we've been demonstrating ever since. When the sky falls, literally, humans don't just survive.
We adapt, we innovate, we persist. The Toba eruption was the worst natural disaster our species has ever experienced, and the evidence suggests we came through it not despite our intelligence, but because of it. Lake Toba still sits there today in northern Sumatra. Deep, blue, beautiful. A caldera where the world almost ended. And above it, on the rim, people live. Farmers, fishermen, families. Living on top of the thing that almost ended everything. That, somehow, feels like the most human story of all. If you want more, subscribe and hit the bell. Don't miss what's coming next.